Okay, what you see before you is the process control trainer used in industrial instrumentation, and the whole idea behind it is controlling the process. And in this particular one, we're going to be controlling flow from the tank at the bottom to the tank at the top. And what we're trying to do is control this variable, and the variable, of course, is moving water from one tank to another. And in the real world, we might have instances where we're bringing water in from an outside source, using it as part of our process, and of course the outside world may supply that water at various rates. Our pump may have times that it doesn't maintain pressures, or we need more pressure because we need higher draw, so we may not have a consistent need for water, but we may have a consistent need to control that level of water. And that is ultimately what we're going to do with this trainer. We're going to look at difference between open loops and closed loops and those type things. And you're going to have with this there's a handout I'm looking at. It's on page SO29 that tells you everything you have here as far as the mechanical side of things. And I've got a picture of all this control stuff, which includes a PID controller, which you'll understand a little more about, a flow transmitter, all the relays and sensors and outputs and inputs, DC power supply, your discrete I/O, switches and lamps basically, your process meter, and so forth. You'll have a picture of this. So what you're doing, or what you will be doing as part of this, is understanding how we do what we do through each step of the process. So I'm going to begin kind of at the beginning, which makes sense, and work you through the more complex stuff on here. So just wanted you to have a quick view of the trainer and kind of an understanding of where we're going to be going. And what I'm going to do is I'm going to set up these experiments and kind of talk you through what it's doing, let you have a look at what the changes are, and then quiz you on your understanding of that. So if you have something in the video that you don't understand, please get with your instructor before taking the quiz. So I'm going to pause the video now, go ahead and set up the first experiment, and just start running through these things for you. Okay, I am in the experiment in Introduction to Process Control titled, let me get back, Manually Control the Liquid Level in a Tank Using Open and Closed Loop Methods. Now it's hard to see water, but this tank is full. It's to this level right here, which is about what it says we need to have to be full. And I have went through and made sure the reservoir was full, made sure the appropriate valves were either open or closed depending on the state that it asked. Pressure is hooked up air pressure wise, but it's not needed. I have built the circuit to control the circulation pump. That's these three wires up here. In essence, what we're doing is we're taking 24 volts through a switch to turn on the circulation pump. So my switch is off right now, so my pump is not running. My valves are set per the experiment, and we're about to plug this in and turn it on. So I'm going to turn it on, and the very first thing it does, asks us to do, make sure that the light is on, so I'm going to do that. Now this is on the side, you won't be able to see it, but I will let you know verbally. And you probably saw the meter come on, the process meter, along with the PID. So we do have life here. So we are alive, and so we've got the power. Now ask us to turn SS1 on, and when I do that, you should hear the pump, but we're not going to have any flow. And I don't know how well you can hear that, but I can hear the hum of the pump now. And you can actually see the pressure on the pump rising, and I'm not going to run it long because we're not moving water, and I don't want to damage that pump should. But it says even though the pump is now running, there's no flow because we've got the manual flow control valve, which is FV100, closed. So these are our manual control valves here. This is on that same sheet. that I told you about that was on page SO29 in the book I have. I'm not sure if it's the same in your book or not, but it's just a nice picture of all the mechanical aspects, so hopefully you can see that well enough to find that picture. If not, pause the video and have a look. Now it says open the manual control valve here, and that is the one located right here. So I'm going to turn the pump back on, and I'm going to open that valve by turning it counterclockwise to where we see this gauge get to 1.3 gallons per minute right here. So that's what we're going to be looking for is, excuse me, I think it's this gauge. I think I pointed to the wrong one here. Let me make sure I'm showing you the right one. Flow valve 100, yep, HFV. So that's this guy. And excuse me, it's this gauge that we want at 1.3, so I was pointing to the wrong thing. So just trying to get ahead here. So I'm going to turn on this, and the reason I'm sitting down is to hopefully let you see a view of what's here, and I'll step out of the way. So I'm going to adjust this valve here, and you're looking at this silver bead here, and I'm going to take a picture of that. And there's a little red indicator that I need to line up, and I'm going to do that for you, hopefully. There we go. So that's about 1.3. And if you can look, you can see my tank is rising. While it's rising, I'm going to get a picture of this flow valve to include for you, because there's something we're going to need to do in just a moment. So there's that. So as it's slowly rising, it says increase the flow by adjusting flow control valve until level reaches, wait a minute, I think I got ahead of myself. Let's see, when the level of the process tank reaches 5 inches, open the process tank's right side manual drain, which is HV4, which is this guy here, being on the right side. So we are about 2.5, so I'm going to let that continue to rise up, and obviously at 1.3 gallons per minute, that's going to take a few more seconds, but when we do, we'll let that down. And basically what's going to happen is it's going to allow water to drain from the reservoir and cause the process tank to begin to drop, because there is now a demand on the system. So what we're going to try to do is increase this flow to maintain 5 inches in spite of that demand. And this is an open loop system where we're trying to manually respond to changes in systems by adjusting it ourselves. In other words, there's no automatic adjustment. We're having to take care of that ourselves. So we're approaching 3.5 inches, so it shouldn't be too long before we're at 5. And it asks us to open that valve about halfway. So if you can't see the tank, I'm going to use my pen here. If you can't see the water, we're about right there. 5 is about right here. We don't have to be dead on. We're going to get close though. And so what we're doing is we're pumping water from this bottom tank through our system manually to our top tank. And when it hits 5 inches, and it's not far, in fact it's about there, we're going to start using some of the water out of that tank. And obviously if we're using faster than we're supplying, I've got that valve set such that we have to do something if we need to maintain this level. And what I'm going to do is increase the flow here and try to get us back to where we're maintaining 5 inches. We're still falling now. Still falling, and looks like we're about maintaining now, so I'm going to have to increase a little more to hopefully rise. And if we're not rising now, yet we are slowly but surely we're putting back. or maybe we're just maintaining. I'm gonna back off that valve a little bit where we're still using, but hopefully we can keep up with it. Set about halfway. I've got it a little more open than halfway there. But down a hair more. Now we're rising for sure. So I'm gonna let it get back to 5, and of course now that we're rising, we're gonna go past the 5 mark. So once we hit 5, I'm gonna have to adjust my flow rate again to try to maintain that 5. So you can see this is just gonna be a constant battle on my part to maintain. And this is an open loop system. Think of it as you're driving your car on the interstate and you're trying to maintain 70 miles an hour. Well, if it's no wind blowing and you're heading down pretty much a flat area, and I'm gonna have to adjust this valve down a little bit because we are, so I'm gonna drop it some, and we'll see in a minute if we're holding 5. But you're heading on this flat area, there's a point where you'll get your foot properly aligned on the gas pedal to maintain, and we're rising a little bit, to maintain 70 miles an hour. But if you hit a hill, that place that your foot's at is not going to keep you at 70. You're going to have to increase your speed. Or if you're going down a hill, you're going to have to let your foot off. You're going to have to decrease your speed. That is an example of an open loop system. We're going over 5 again, so we'll have to back down some more to hopefully maintain. But then we have cruise controls that do maintain that for us. That's more of a closed loop system. It's getting feedback. It's knowing. Now we're getting feedback by watching our speedometer, but we're having to respond to that manually. There is no electrical process that controls it. So that's the difference between an open loop and a closed loop. We're pretty well maintaining. We're not at 5, but we'll pretend we are. I could keep battling back and forth doing this, but the concept is to let you see that. So we're pretty much stabilized. If we're moving at all, it's very slowly. I can't see any difference. We're holding about 5.5 inches or so there. It says now demonstrate the effect of a disturbance by slowly closing the right-hand drain some. So I'm going to take it down to about 1/4. So we're going to obviously be using less. We're going to disturb the process. And by doing that, we're seeing our level rise. And we did get it to stabilize, but then all of a sudden something happened, the rate changed, and we would have to go back again and manually step down our flow to respond to that. And I went the wrong way, and if we're not careful, that could happen. So you can see there's some downfalls to this. So this is that manual open loop control. So now it's saying we're trying to restabilize it again. So I'm going to open it back up so we can get close to 5 inches. I don't want to burn my pump up by getting the bottom tank too low. But I'm going to see if I can work between the 2 valves. We're still following. Shut it off a little more. And we're pretty close to stabilization there. We're falling just a little bit. So I'll increase this side some. Oops, wrong way. There we go. And we'll see in a second if we're falling or rising. So we're having to manipulate one variable, which was flow, to control another that is level. That same thing can be applied to our pressing of the gas or letting off the gas to maintain speed. So we're having to change our pressure on the gas pedal to maintain speed of the car without some kind of closed feedback system. We're falling a little bit, so I'm going to go up a hair, see if we can control. And that's pretty much this. This is to give you an idea of an open loop system. This is a perfect example of what we would see with an open loop system, is that constant battle when variables change to maintain another variable here. So as the flow changed, so did our level. So it's a back and forth to keep that going. We're dropping just a hair now, but we're at 4 3/4. Drop it a little bit, so I can just increase a little more and bring that up. So you get the idea of what's going on with this particular lab just through that part of the process, and this is a perfect example. And you could probably think of closed loops and open loops. If you ever lived in a house with the old style air conditioners, trying to maintain room temperature was a constant battle of turning the air on and off, or eventually they did come up with the thermostats on them where you could set them. But just imagine if you didn't have a thermostat, if you couldn't set your home to 74 or whatever it is, and you constantly had to go over and turn it on when it got hot, turn it off when it got cooler. That would be an example of an open loop system, but with the thermostats built in, they take care of themselves. So we can think a lot about open and closed loops, and that's just a few examples there.